Welcome everyone. In this video we are going to take a look at Riverpod, and if you're not familiar with Riverpod, that is because it is a new state management solution by the same person who made Provider. And you can also see that Riverpod is an anagram or a play on letters on the word provider. So Provider has the same letters as Riverpod. And yeah, as a quick summary, this is essentially Provider, but it solves some of the problems, or maybe not problems, but it makes some of the normal day-to-day stuff a little bit easier, and it provides a couple of extra benefits that can make your life as a programmer a lot easier. Some of the benefits of using Riverpod over Provider is the fact that it's compile safe, meaning if your code compiles, it works. You won't get any provider not found exceptions. And then Riverpod also has support for multiple providers of the same type, and you can combine asynchronous providers and provide them from anywhere. And then it also doesn't depend on Flutter. You can listen to providers without a build context. So this also means you don't have to worry about passing around build context to be able to read your providers. And one thing that you can clearly see over here is that the documentation looks very neat. And I've gone through all of this and it is very, very good. So credit to Remy for making this package and providing us with this excellent documentation. Honestly, you do not need to watch this video. You will probably be better served to just read the documentation. But if you prefer to learn by watching a video demonstration, then this will be perfect for you. What we will be doing in this video is just creating this simple to-do app, and this example is actually in the documentation. So at the time of recording, the Riverpod documentation has these 3 examples, and as I understand, they are still being developed and refined. But yeah, if you take a look at the to-do list, this will take you to this repository, and this example is the one that we will take a look at today. However, it's slightly tweaked, like the UI is a little bit different, and I also added this search functionality. So yeah, as a quick run through, it's very simple. You can add a to-do, and then you can select the to-dos that are completed. You can see there's a counter here, and then you have your active to-dos and your completed to-dos, and then this search functionality. So if we search for H, it will show everything with an H in it. Same with I, and yeah, one thing that's neat is the search is dependent on the state that you're in. So if you're only filtering for the active to-dos and you do a search, it will only show the active to-dos. Before we actually take a look at the code, the thing that I want to highlight is the fact that this was very easy to do. For me to add this search functionality was extremely simple to just extend the example that Remy gave, and it kind of feels like Lego pieces that you just fit together. I essentially just plugged in the search functionality into the code and it worked. It's not really like that, but that's kind of the feeling that I got just because it was so easy to add the search functionality. So with that said, let's start from scratch and create this application. So 2 things to note is that I'm on the master channel and that I'm also going to be building to desktop. So if you haven't tested Flutter on the desktop yet, or if you haven't built Flutter to the desktop, then I definitely encourage you to do that. It's not always stable, at least not on Windows, but it is a very nice and convenient way for you to quickly prototype things. And you can also have a draggable window, or not a draggable window, but you can resize the window. So it's easy to test for UI purposes. Okay, so the first thing is we would need to add our dependencies. So in the pubsec.yaml file, I'm going to be adding the following 3 dependencies. UUID, so this is just to generate a random ID, and then Flutter hooks, this I will get to later, and then hooks Riverpod. So the reason we're doing hooks Riverpod is because this is essentially Riverpod with the functionality to also use Flutter hooks. And if you're not familiar with Flutter hooks, then this is not really a tutorial on how to use hooks. However, we will be using them, and I think you will get the benefit of using them by just watching this video. But yeah, if you come from the React world, then you will be familiar with what hooks are. It's essentially just a different way of managing your state. In the Flutter hooks repository, they give an example where you have to go through all of this boilerplate to create an animation controller. And the general idea is that instead of you having to do this every single time you need an animation controller, you can instead just call use animation controller. And you do this within the build, and this is exactly the same as this. The only difference is that this method over here handles all of the small details. So this handles instantiating the controller and then disposing of the controller. And the animation controller is just an example. There are a number of different hooks that you can use. I think there's a list. Yeah, so you can see we have a number of different hooks that you can use. And in this video, we will be using the text editing controller. So this is just a nice way to actually just create and dispose of a text controller. But yeah, with that said, we definitely do not need to use Flutter hooks, and Riverpod is not dependent on hooks. So you can see in the documentation, they provide a number of different options. So you can either use Flutter with Flutter hooks, or you can just use Flutter only. So then you would import Flutter Riverpod, and then you can also do Dart only. So if you're not using Flutter, maybe if you're making a command line application or something, then you can just use Riverpod. But with that all said, the Hooks Riverpod package does provide a lot of convenient ways for you to really get up and going with minimal amount of code. And if we quickly take an example, we can actually see, so yeah, in the documentation, they provide examples of how you can use Flutter and Flutter hooks. So what you need to add as dependencies, what you need to add as dependencies if you're only using Flutter, and what you need for only Dart. And a simple example, if you look at the Flutter and Flutter hooks, you would create your provider, which we will take a look at a lot more in a moment. Then you will provide all of the providers with this provider scope widget in your main function. And then with the hooks Riverpod, all you need to do is call use provider and then pass in this provider, this hello world provider that you create over here. And then you can use this value. So whatever value is exposed over here, hello world in this instance, this you will be able to access using this use provider. And to just show you the difference between what it looks like if you use Flutter hooks and Riverpod, if you only look at the Flutter example, now you would need to use an additional widget. So you'd need to use this consumer widget. And if you've used provider before, then you are familiar with consumer. The only difference is that now, instead of consuming and specifying the type, you are specifying a consumer, and then you get this read method. And using this read, you will actually specify what provider you want to read. So essentially, you are subscribing the consumer to the hello world provider, and then you get the value. So these two implementations are exactly the same. The only difference is that this is less boilerplate code for you to write. But yeah, with that said, you definitely do not need to use Flutter hooks, but for this video, we are going to use it just because, in my opinion, it does make the code a little bit more readable. And yeah, I'm a fan of less code, or I should say fewer code. I'm not sure. Okay, so let's jump to our code and actually start programming. So first up, we just want to create a material app. And for now, we only have this home widget, and it's just returning a scaffold with a text of home. And then we're going to create a new file, and we will call this todo.dart, and this will be our to-do model. And instead of me typing it out, I'm instead just going to jump back and explain the code to you. So this model is quite simple. We have a string ID, string description, and a bool that's completed. And then in the constructor, we have named parameters. So the description completed, which we default to false, and the string in this instance, we don't immediately set the string ID. Instead, we test to see if the ID that is passed in is null. So that equal or not equal, this double question mark checks to see if ID is null. If ID is null, then we create a new unique identifier. And this is using the UUID package. So this package over here. And then we're just overriding to string with a description. And that's it. That is our to-do model. Let's go back to main and start building some of the UI. Okay, so jumping forward, I added a couple of extra widgets. So for now, we have this toolbar, a title, and a to-do item. and all of these are just returning a text widget for now. And then we expanded the home widget. So if we go to main.dart, in the home widget, we are now using the use text editing controller, and this comes from Flutter hooks. So as I said, instead of us creating a editing controller or a text controller and then disposing it, now this just manages it for us. So we don't actually need to be in a stateful widget and manage that entire life cycle. It's just a quick and easy way to get access to a editing controller. And one thing to note is that if you do make use of the Flutter hooks package, then you won't extend a stateless widget or a stateful widget. You need to extend the hook widget. So this comes from Flutter hooks as well. So now that we extend hook widget, we can use Flutter hooks without any issues. So let's save this, and then after I run it, I'll go through all of the other code. Okay, so for now, the only thing we have is this text box over here that says what needs to be done, and we can enter stuff, and nothing will happen at this current moment. And yeah, just to run through the code, we're returning a scaffold, and the body is centered, and this has a child with a constraint box, and the constraints are a max width of 800. So basically, no matter how big we make this window, it will be a maximum of 800 in its width. So I just like this. I don't like it to be as big as possible, especially on like a big screen like this. So yeah, and then we have a list view, and then in the list view we have a couple of to-dos. So this is where we will actually add all of the to-do items. So we have our title, and then in the onSubmitted for this text field, so when we actually press enter, then the onSubmitted will be called, and this is where we will actually add the to-do. And then we have our columns, or sorry, not our columns, we have the actual to-dos. So this toolbar over here is where we will set whether it's filtered, where we can search for specific to-dos, and then here is the actual area where we will add the individual to-dos. So this will be the to-do list. One thing that we can add right now is the title. So let's just add the title, and I'm gonna replace this title over here. I'm just gonna copy and paste from my previous example. So this is just a row, and it has a text of to-dos, then the text is styled and aligned, and then we have an icon, so the checkbox over here. And both of these have this static or constant value with the size. So if we refresh this, this is the current state of the app. We have our title and we have our text box. Okay, so next up, we will need to add the logic that will actually manage the list of to-dos. So I'm just going to create a new class and call this to-do list. And this will extend a state notifier. And if you're not familiar with what a state notifier is, I have a dedicated video discussing a state notifier in detail. But yeah, as a quick summary, it's basically a value notifier, but with extra functionality, and it's not dependent on Flutter. It's really simple to use, and I think it will be clear from this example how you can use a state notifier. And yeah, also this is made by the person who made this package, so Riverpod and Provider, and hooks as well. So this is one big family of packages that he's made. And yeah, to use state notifier, we will actually need to import that package. So I didn't add the package to my pubsec, but it is included in the other packages. So yeah, you can just go and import state notifier and state notifier.dart. And here we need to specify the dynamic type. So in this instance, this will be a list of to do. And there we go. And we would actually need to call super, and we need to initialize the first state. So this is basically the initial state, and that's how a state notifier works. The state is specified by this type over here. So we will have a state of type list to dos, and we need to say what the initial state is. So in the constructor, we are going to make this a optional parameter, and I'm just going to rename this to be initial to-dos, or we can also say initial state. Maybe let's call it initial to-dos. And then in the super call, we're going to see if this is 0, so we're going to do a check. If it is 0, then we will just pass in an empty list. Now let's create a method called add, and this takes a description, and all this does, it adds a new to-do to the list. So to update the state, we would need to create an entirely new to-do list, and we do that by just setting the state like this. So this state over here is a setter. So in the state notifier class, this is a set method, and we are just giving it a new state by creating a new list, and we are unpacking the current state that we have. So the current list, it will take every single to do, and this is what this ... is. So it's just unpacking it into this new list, and then at the bottom of the list we are creating a new to do item with a description that we pass in over here. Then next up, we will add a toggle method, and this toggle will take the ID, or we pass in the ID, and what it does, it sets the to do to be completed or uncompleted. So the exact same thing, we are setting the states with a new list, and then in this new list we are doing a for loop, and then we're doing a for loop for each to do in the state. So the state is a list of to-dos, as you can see over here, and then we are checking to see if the to-do.id is equal to the ID that we specify over here, and if it is, then we just change the completed state. So by saying exclamation point means it's the opposite of whatever this current Boolean value is. So if it's false, then it will be set to true. If it's true, it will be set to false. And then if it's not equal to this ID, then we just return the to do, and we don't do anything on it. And then next up, we will add a method to actually edit the to do. And we're currently getting a warning because we also need to import meta. So I'm just gonna import meta /meta ... and this takes in the ID and a description, and these are name parameters, however they are required. So same thing, we are setting the states, creating a new list, and then iterating over every to do in the list, and then we're checking to see if the ID is equal to the ID, and then if it is, then all we're doing is we are overriding the description. So now we're setting the description to whatever we are passing into the edit method over here. And then finally, we have our remove method. So here we just specify the target of the to-do that we want to remove. I guess we can also just apply the ID over here, and then we're creating or setting the states to be a new value, and this is by using the where method. So on the current list of to-dos, we are calling where, and we're checking to see where the to-do ID is not equal to the target ID. And then based on this condition, we are just calling toList to actually create a list. And this is important. If you forget to call toList, then it will actually return an iterable. So this returns iterable to do, and we want this to be a list of to do. So just remember to actually call toList over here. And that is that. That is basically all the logic that is needed to manage our list of to-dos. So now we are getting to the fun part, and this is where we will actually start using Riverpod and see how we can integrate the providers with our UI. So if you are familiar with provider, then you might be thinking, okay, we are gonna create a new widget over here. So for example, normally we would create a provider widget, and then we would create the provider, and then we would have a function of a context, and then we would actually create the provider. However, Riverpod is slightly different. In Riverpod, we actually create global variables like this. So we would create this to-do list provider, and then we can actually just import all of the necessary things that we need. And yeah, so how this works is we create our provider as this global variable over here. And yeah, you don't have to be worried about the fact that we are creating global variables, because we are actually inserting this variable into the widget tree. So this is only used as a reference of sorts. For our widgets to actually be able to read the value of this provider, we need to wrap our main app in a provider scope widget. So the provider scope essentially takes all of these global providers that we define and inserts them into the widget tree. Maybe I'm explaining that wrong, at least that is how I understand it at this current stage. And just to clarify, I've only been using this for a little bit. I'm also still learning this package. But yeah, with that little disclaimer out of the way, let's continue. So in this state notifier provider, this is very familiar to what we've probably seen before, or what you may have seen if you use provider. We specify the type of provider. So you may be familiar with a change notifier provider as an example. And then you specify the type of the change notifier, and then you get the context, and then from the context you return the actual provider. However, this is slightly different. Here we are using a state notifier provider, and if you remember in the to-do, we are extending the state notifier, and then we're specifying that this is of type to-do list, this one over here, this to-do list, and then we are getting this provider reference. And what this allows us to do, the reference allows us to actually read the value of other providers. And we will be taking a look at this later. For now, we don't actually need to use the reference, so we can actually just underscore that. What we are doing, in fact, is we are just returning a to-do list, and we are instantiating an initial value. So we're just creating these 3 to-dos as an initial value for our list. So let's just save this. And yeah, very, very important, you need to add this provider scope. So one thing that you may be cringing at is the fact that I'm adding this to the main.dart file. And yeah, that is a question of how can we separate the logic between our business logic and our actual UI. And for that, I don't have a clear answer yet. In the example that they gave, they just add everything into the UI folder or into main.dart. And that is probably only just because it is meant to be an example. And as this is a very small application, there is no real reason to over-architecture this. But that's actually not the point that I'm trying to make. The point that I'm trying to make is that it doesn't matter where you add this global variable. It doesn't need to be in main.dart. It can be wherever the logic best pertains to where it should be, I guess. It can be in this to-do file over here. You can create a dedicated folder for all of your business logic, or you can create a dedicated file. It doesn't matter because it is just a global variable that can be used throughout your application. You just need a reference to this to-do list provider, and then the Riverpod package will sort out the rest for you. For me, it makes a little bit more sense to actually add it to the to-do.dart, at least for this example. So instead of adding everything to main.dart, I'm just going to contain all of the logic that pertains to the to-do list, the model, and everything regarding filtering and actually instantiating the to-dos. I'm going to keep this in to-do.dart and then make sure that our main.dart is only for UI. So let's continue to build the actual logic for this application. And next we will add this enum called to-do list filter, and this will have 3 filter types, all active and completed. So this just filters the states of the current to-do list. And then below this, we will add a new provider, and this initial one that we made was a state notifier provider. And now we're creating something that's a state provider. And you can see that the description is that there's no fancy logic behind manipulating the value, since it's just an enum. So in this instance, what we're doing in the state notifier provider, we will get a reference, this provider reference, which we don't need. And we are initially just returning a filter with the filter specified to be all. And then later on in the app, you will see it's as simple as just updating the value of this to-do list filter, and that will change the value of this specific state provider. This will become a little bit more clear once we actually start using this filter. And with that all said, you may think, okay, we are now ready to actually populate our UI. And technically we can. With everything that we have here, we can just read the value of the to-do list provider, actually get the value of this state notifier. So we'll get this to-do list, and then we can use this to-do list in our actual list. So where we want to create this list over here, and that will be good, done and dusted. We can just display the entire list from that value. However, for our specific application, we want to filter the to-dos. We want to filter the to-dos on this to-do list filter, and then later we also want to add the functionality to search for specific to-dos. And this is where Riverpod comes in with a new, I guess you can say, concept, and that is called computed. So the computed is basically a way to do expensive operations that would normally happen in your build method. So as an example, instead of us going in our build method and reading the value of the provider and then filtering the list based on that value and then displaying the list, the computed allows you to do that automatically. And the reason that you want to use computed is because you sometimes don't have control of when the build method gets triggered. The build method may be triggered for a number of different reasons. It might be because a parent widget updates, might be because of a layout change. So for example, if I drag the window like this, every time I do this, the build method gets triggered for these widgets because they need to rebuild and they need to resize and relayout. This isn't always the case. You can do things to prevent that. For example, constant widgets or caching widgets. But the point is that you want to avoid expensive operations in your build method. So we don't want to read the value of our to-do list here and then in the build list filter that entire list. We want to do that one time and one time only. And that is where the computed comes in. As you can see, computed is generally used for performance optimization, and there are two main reasons. You want to optimize the number of rebuilds made by your UI, and computed can help you with that by allowing widgets to listen to only what they need. And then also you have an expensive operation. So for example, the UI sorting a list, which is semi what we're doing. We are filtering a list and searching a list, and we don't want to re-execute all that logic every single time. So again, I definitely recommend you read the documentation for extra clarity if my rambling doesn't make sense. But let's jump back to our example and actually use computed, and it might be a little bit clearer to see how we use it. So let's create a new provider, and this will be the computed one. So we will call this filtered to-dos, and this is a computed. And in the computed, we get a read, and then we will use this read to get a reference to our other providers. So as an example, we will create a final and filter, and then we will read, and we are going to read this to-do list filter. So this read method over here is, as I said, provided by computed. So we're just going to say to-dos filter, to-do list filter. And there we go. So now within this computed method, we are reading the value of this to-do list filter. And we want to do the same for the to-do list provider. So let's create a final to-dos, and we will read the to-do list provider. And important to note here is that we want to read the state to return the actual list of to-dos. And now the very important thing, or the very nice thing about this, is that computed will only be triggered when these providers change. So when we get a new value from the to-do list filter, or when we get an update to the actual list of to-dos. If these do not change, then the computed value will not be, or this computed will not be triggered again. And this allows us to use computed in our UI, and no matter where we read this computed, or if we read it from multiple different points in our UI, it will always return the same value, and it won't recompute all of the logic that is here. So this is why this is a performance optimization, because if we do expensive logic within this method over here, it only gets done when necessary, and it won't be redone even if we do it from multiple parts in our, or call this method from multiple parts in our UI. Now what we want to do is we want to create a switch. So this is a switch on the current state of the filter. And what we're saying is, if it is completed, then we want to create this new list of filtered to-dos, and we return the to-dos where the to-dos are marked as completed, and then we call to list. And same for active. Here we want to return all of the to-dos where they are marked as not completed, and then we call to-do list or to list. And then finally all, we just return all of the to-dos. So the reason that I'm creating this filtered to-dos is because we are going to be using this later on for the search as well. If you don't want the search functionality, then you can also just return your to-dos like this. There's no point in creating another list. But yeah, as you will see later on, we will use this filtered to-dos to also search, or to also incorporate the search functionality. And then last but not least, we obviously need to return this. So I'm just going to return the filtered to-dos. And now we are actually ready to use this in our UI. One thing we should do is we should give an explicit type. So I'm just going to say that this is a list, if I can type, a list of to-do. Okay, and then back to our main.dart. Now we actually want to read the value. So I'm going to create a final to-dos, and then using a hook, we will call use provider, and then we will specify the filtered to-dos. And that's that. Now, whatever is computed in this filtered to-dos, whatever is returned over here, we got access to that now in our home widget using the hook over here. And then now we can use this to-dos. So as we would normally use in UI, this is just a list of to-dos. So as an example, we can just unpack a list, and on the to-dos we will call map, and then we will create a text widget, and then based on the value, the current to-do, we can just call description, and this should work. Let's do a hot restart. Or actually, let's stop and start again. And there we go. Windows, or at least the Windows build, just required a force stop and restart. On mobile, that would not have been needed. But yeah, like I said earlier, definitely check out the desktop. It's still very, very cool just to be able to drag your screen like this. And it's very nice for prototyping UIs. As you can see there, we just saw that this is giving an error because we're not doing the necessary conditions for when the screen width is very, very small. But that's not the point of this video. But yeah, as you can see, we have our list of text widgets over here. So okay, let's just get rid of those errors and just restart. And let's make this actually a little bit nicer to visualize, or a little bit cleaned up. Okay, so let's get rid of this list. And I'm just gonna copy paste this from my previous example. Oh, I shouldn't say my example, from the Riverpod examples. And what we're doing here is we are checking to see if the to-do list is empty or not. So if it's not empty, if there is something, we return this divider, and then we're doing a for loop for all of the to-dos, and then we're checking to see if the current item is bigger than 0, then we return another divider. So this divider logic is just to make sure that if there's no widget, we don't return an actual divider. And if there are, we return dividers between them. And then we have this dismissible widget. And if you're not familiar with dismissible, it allows you to drag or swipe away a to-do item to remove it. And yeah, and then for the dismissible to work, it needs to have a unique key. So we will set the value key to be equal to the ID of the to-do item that we currently have. And then on the to-do list or on dismissed, this is where we use the providers again to actually call the remove method. So this is a slightly different syntax than what you might be used to when you use provider. What we do is we use this to-do list provider, this global variable over here, and on that we call the read method, and then we pass in our context, and then we just call whatever method we want. So we call the remove method in this particular instance. And what this will do is just remove the to-do from our list. And then fantastic, now we also need to just modify our to-do item widget. So currently we don't have the to-do item implemented. Currently it's just returning this custom text. And I'm going to cheat again, and I'm just going to copy paste from the example. So now this to-do item is extending from hook widget, and we are passing in a to-do, and we're extending hook widget because we will be using a number of different hooks. So the first one that we will use is the focus node, and this allows you to put focus on a specific area. So for example, a input box, or the next button that needs focus, as an example. And if we take a look at the source code, again, this is just using a focus node. So focus node is from the Flutter widgets. And for a focus node to work, we need to also use a listenable. So we're just going to pass in the item focus node to this listenable. And what the listenable does, it marks the widget to rebuild when this listenable changes. So in this instance, the listenable is this item focus node. I'm not going to go into more detail regarding that because the point of this tutorial is just looking at Riverpod and not taking that much of an in-depth look at the UI. But yeah, we also have another text editing controller, and this will be to actually change the value of the to-do. Or I shouldn't say change, I should say edit the value. And then we also have a focus node for the actual text box as well. So as an example, the item focus node, we are using this in the list tile. So if we tap on tap, then we are requesting focus on that item focus node. And the same for the text field focus node. Here we're using this in the text field and setting the focus node equal to that. And if we tap on the actual list tile, then we request focus. And then here we have the parent widgets, this focus widget, and this is the item focus node. And as you can see, when the focus changes, so when we tap out of the editing box, then we will do this logic over here. So if it's focused, we will set the text to be equal to the to-do description. And otherwise, if it's not in focus, it means that we want to update the text, or not the text editing controller, we want to update the to-do. So then we call the to-do list provider. So the to-do list provider is the very first provider that we created, this one over here with these initial values. And then where's the code now? Okay, and then we read, or we call the read method, and then on the read method we just call edit. So this allows us to call the edit method on our to-do list over here, and then we just edit the description value as we discussed previously. And then finally in the child we have a list tile, and we've discussed the on tap. Then we have our leading checkbox. So depending on whether the to-do is completed or not, if it's completed, then it has a check. If it doesn't, then it's not checked. And as you can see, we have this on change as well. So this checkbox allows you to tap it, and if you tap it, we just toggle the current to-do item by calling the read method on the toggle list provider. And then finally we have our text field where we can actually change the description of the input. And that is that. So let's refresh and you can see we should have the updates. Let's try again. Okay, that is the curse of using desktop and being on the master branch. I'm just going to rebuild. And there we go. Now we have our actual list over here. So currently I don't think, we haven't done this feature yet. We can't add a to-do, but yeah, we can toggle these to-dos, and this will actually change the provider as well. And we can also swipe them away and we can delete them. Okay, so next up we want to add the to-do. So we want to add this on submitted. So the unsubmitted is in the text field. So this is when we call submit on the text field, or automatically if we hit enter on our keyboard. And what we want to do is we want to again get the to-do list provider, call the read method, and then just add. In this instance we call the add method and we specify the value. So in this instance we are passing in the description of the to-do, and then we just clear the controller, and this controller is from this text editing controller, which is from the hooks package. And if we refresh, hopefully this time it will work. Let's add something. Nope. Let's rebuild again. Okay, let's see if it works. And yeah, it works. So now every time you add a to-do, there you go, it just adds it, and everything else still works. As it comes or in regards to deploying to desktop, maybe scratch what I said before, maybe don't do it yet. It's at least from like the hot refresh or the hot reload or hot restart, whatever, it's not that convenient yet, but it's still very cool that we can deploy to Windows. And at least the app looks cool on Windows. But yeah, regardless, let's continue. What we want to do now is we want to add our toolbar. And again, I'm just going to cheat. So let's call the toolbar. And currently all this does is returns a text. So I'm just going to paste in from the example. And I see, okay, I named it wrong. It should be small letter b. And you will see that I copied in the search, which we haven't actually done. And there's this other one, this uncompleted to-dos count, which we also still need to do. So for now, let's actually just remove all of this. And the same for this search over here. So let's save and just see what the UI looks like at the moment. Okay, so we have everything the same. The only difference is we have this toolbar over here. And now if we toggle between these different ones, it should filter based on if they're completed or not. So here's all the active ones. If we click high, it should disappear, and now it should be in completed, and all should show all of them. So perfect. One thing that I didn't say the previous time is to see if the editing works. So now if we tap on one of these, we get focus to it, and let's say bonjour again. And yeah, now it's updating them. And we can still delete, and we can still add to-dos. Okay, perfect. So now what we want to do is we want to incorporate these additional things that I removed. And the first one that we want to do is this uncompleted to-dos count. So let's jump back to our to-dos, and we're going to add another provider, or we're going to add another computed. So just before the filtered to-dos, I'm going to add the uncompleted to-dos count. And again, this is a computed, we get the read, and then in this instance, we are actually using the read to get the to-do list provider state, same as we did before. And then on the list of to-dos, we are calling where. And we are getting all of the to-dos that are marked as not completed, and then we are just getting the length. So this means that in this instance we are returning an int. And yeah, now we can use this uncompleted to-dos count. And again, because this is a computed, this computed will only ever be called when the to-do list provider changes or when the list of to-dos changes. So even if the list of to-dos is of a different length, or if it's the same length, I believe it also won't actually be retriggered. So if we take a look at the example, they say by using computed, this value is cached, making it performant. Even multiple widgets try to read the number of uncompleted to-dos, the value will be computed only once until the to-do list changes. And this will also optimize unneeded rebuilds if the to-do list changes, but the number of completed to-dos doesn't, such as when editing a to-do. So yeah, to explain that, let's actually first get the UI going, and then I'll explain it a bit more. So here we want to re-add this, and what we're doing is we are using a provider, and again this is a hook. So as you can see, we don't need to use the hook over here, we can use it over here. So calling use provider uncompleted to-dos count, and this is an integer, and then toString items left, and this is the first time that the refresh worked. Now you can see we have 3 items left. So if we add another one, it will be 4 items left. And now this has got updated because the actual length updated. It's now 5 and now it's 4. But if we were to just change this to high again, this won't be recomputed because the length didn't change. So a slight little performance optimization that we got there. Or I guess it will be recomputed, but at least the UI wouldn't be notified because we are getting an integer and the integer value is still the same. So this use provider or this text widget won't be rebuilt, at least. One thing that I forgot to mention is that to filter the list of to-dos by a specific filter type, it's very easy. So we have these 3 flat buttons over here, just wrapped in a tooltip so that it has a message if you hover over the button. And then depending on the specific button, in the first one, if you press on press, then we just call, or not call, we set the state of the filter to be equal to the to-do list filter .all enum. And the same for the other one. Here we set it to be active, and here we set it to be completed. So if we go to this filter, this is where we call use provider and the to-do list filter. And this to-do list filter is just a state provider. So to update this state provider, it is literally just resetting the value. So as you can see here, we are just reassigning the state to be equal to whatever value. Okay, and finally, we want to add the search functionality. And this is where I feel like this entire solution is so nice, because it's so easy just to add the search functionality. So we have all of this ready and going. If we go to our to-do file, and you can see we have our to-do list filter, which we are familiar with. And just below this, I'm going to add a to-do list search. So instead of this being an enum, this is just going to be a string, and it's a state provider. And then now in our actual filter to-dos, we are just going to do the same. So I'm going to say search, and instead of now reading the filter, I'm just going to read the search. So to-do list search. So this is whatever the value is of the search. So this string value. So if we actually start implementing the search and make this like an A, then this search value will get updated, and based on this value we can do additional logic to do the search. So just below the filter, we first want to filter all of the to-dos based on the filter states, and using this filter to-dos, we're going to do another if check, and we're going to say if the search states, so if search states is empty, then we just return filtered to-dos and nothing happens. Otherwise, we call filter to-dos where, and then we can say where the to-do description contains search state. So this is just some string manipulation to see if our current description contains the actual search value. And then based on this, we call ToList, and then we can remove this initial return that we had. And then back in main.dart, we need to add the search. So in this text field over here, this is this one over here in this text field, when we actually call on changed, so every time we tap something and we just want to say search.state equals value, and we also need the search. So we're going to call use provider to-do list search, and that is that. So now I do believe if hot reload works or hot restart works, if we type in H, nope, let's do a restart. And let's see if we type in H or Y, yeah, nothing shows if we type in Y. If we type in H, only that one. If we type in E, only hello, O, bonjour, you get the idea. Let's make hi and bonjour as completed, and then we can also just search in the completed one. So now it's essentially based on what is showing over here, or it only searched based on the filter that is applied as well. So great, everything seems to be working as expected. One thing that we can also add is the ability to change our focus. So for example, now we are focusing on this. How do you unfocus this? Currently, like, you need to go to a new thing. So currently something needs to be in focus. And yeah, this is a quick thing that we can do in our home widget. We're just going to wrap our scaffold with a new widget, and it will be a gesture detector, and then on tap we will just call focus scope with that off context and unfocus. So let's see if hot restart works. Now if we tap outside, so yeah, I'm typing in this text box over here. If we tap anywhere out, it loses focus. And yeah, that's what we want. And that is basically that for this tutorial. Just a quick little introduction. I should rather say me playing around with Riverpod. There are a couple of different, or not different, other things that we haven't explored in this video. However, this video is getting a bit long. One of them is called families. So I do encourage you to read the documentation. It's quite simple. It's essentially just a way to access different states depending on certain conditions. So for example, they have a good example where it's a locale. So instead of just getting the locale or getting this string value, you can also pass in certain conditions. So in this instance, based on the locale, you can do an if checked, and if it's this, then return this. I do encourage you to read the documentation, and I'm sure there's a multiple different neat ways that you can use families, same as the way you can use computed. And then there are also other examples as well, and a more fully fledged app with this Marvel API, but I do believe at the time of recording they are still developing this or still refining everything that goes into this example. And yeah, one thing that's very cool about Provider or Riverpod is the fact that if we take a look over here for futures, let me just find the example. Yeah, here's the future. So in this instance, you can see that they're creating this future provider, and then it's an asynchronous function, wait, and then it's passing JSON from this file. And the cool thing about this is we are still using use provider configurations, this one over here, and then this allows us to call .when. So configs.when, and then you will get these different conditions. So for example, if it's loading, you can show a circular progress indicator. If it's an error, you show the error, and if it's data, you show the data. So it's just a way to ensure that you are handling all of the conditions. You won't forget to handle errors in your UI if you use an approach like this. In the future, if I make more videos on Riverpod, or if I actually start using it in bigger applications, then I will definitely make more videos on how this can be extended, and maybe how we can organize our files as well. But yeah, at least from my initial impression, I really like this, and I can definitely see myself using this. It was honestly a pleasant experience to learn, a pleasant experience to read the documentation, and to extend it with the search functionality. Although that's all I did in this application, it was so easy and so fun that I was definitely very impressed. So yeah, if you are still here, thank you for listening. I hope you found value in this, and let me know if you plan on using Riverpod and how you are using it. Until the next video, cheers.